In this lecture, we're going to review another statistical test called the Wilcoxon t-test or the signed rank test. So this is somewhat similar to the sign test, except that the data will be ranked in terms of magnitude, as opposed to the sign test where the only concern was just the number of positives and negatives. But it is similar to the sign test in that this is a statistical procedure that is used when the data or when the research design has two related samples in a repeated measures fashion. And so here we have two data points collected on each case or each participant in the study. Now, these data are collected as interval or ratio data, but instead of analyzing it as ratio data or interval data, those data are converted to another form, which are ranked data. And that will allow a unique way to analyze the differences across the two testing time points and not violate some of the assumptions that is inherent to parametric statistical testing. So the same participants are evaluated twice, and there are 8 unique steps. The first 6 involve the progressive way to determine the test statistic. So the first step is to determine difference scores for each pair of scores. So essentially the first score subtract the second score for each research participant, and remember, these data exist as interval or ratio data. The next step is to determine the new number, the new sample size of scores that are non-zero. So you could have a score that's negative, another one that's positive, but the non-zero scores are the only ones considered in moving beyond step number 2. And then those difference scores are assigned ranks, provided that those different scores are non-zero. And in assigning the rank ordering of the magnitude of the scores, the sign of the difference, whether it's positive or negative, is ignored. And so the first rank, or the difference that is given a ranking of 1, is actually the smallest magnitude difference between the two sets of the original raw data. At that point, the ranks are separated using the sign of the different scores. So the negative scores are collected into a column, and then the positive scores are collected into a separate column. So they are organized after step number 3. And then the ranks are added up separately. So all the positive ranks are added up, and all the negative ranks are added up. And then as we move into step number 6, then step number 6 will carry forward the first 5 steps to calculate the actual test statistic, and that's the Wilcoxon t obtained, and this is based upon the data. And so the smallest sum of the ranks is the actual test statistic moving forward. Now this is a two-tailed test, and this is what is highly recommended, because in testing this from a one-tailed perspective, the researcher would have to predict whether the differences are either positive or negative. The advantage of the two-tailed test is it keeps the researcher's mind open that the significant difference could be positive or it could be negative. But when one makes the commitment of a one-tailed test, then the prediction has to be one or the other. The option to examine the other one won't be available. And so finally, in step number 7, we take our calculated test statistic and then we compare it to a critical test statistics from what's called the Wilcoxon table. And the Wilcoxon table is based on the number of pairs, so this is the study design, of the non-zero differences, so we have a new sample size, and unless stated otherwise, we always go with the type 1 error rate of 0.05. We then compare the two statistics, the obtained t with the critical t. And we make a determination of statistical significance if the obtained t from steps 1 through 6, so this is based upon the data, is significant if it's less than the critical t-value from the Wilcoxon table that you'll see in the next number of slides. So once again here, the first three bullet items are the identical points from slide number 37, but just as a reminder, once again with the Wilcoxon T, this is a repeated measures type of statistical procedure where interval or ratio data, the raw data, are converted to ranks, and the parametric equivalent to this would be the paired t-test. And this is a little bit different than the paired t-test. In this case, the null hypothesis is evaluating if the median difference is 0, as opposed to the parametric t-test, which is based upon averages. And the alternative to this, to the null hypothesis, is assessing if the population, if the median difference is not 0. So let's take a look at an active example of some data that we see here. And in this particular study, the reaction time to seeing two different colored symbols on a computer screen, whether the symbol is red or the symbol is black, is evaluated in terms of how fast a person can see that symbol, visually process it, and react to it by pressing a button. Now, in this case, we have 10 research participants, and each participant was measured twice. So each participant had the reaction time measured to a red stimulus, and then some point later, they had the reaction time measured to a black stimulus on a computer screen. And from a research design perspective, these could have been assigned in a counterbalanced way in terms of which subject viewed which symbol first, or in a random order. But for our table and our data, we just collected all under red and all under black, and the unit of measurement here is the millisecond. So you see a range of raw data here. We have some very fast reaction times, such as 540. We have relatively longer reaction times, as long as 1.105 seconds, or 1,105 milliseconds. So the first step is to take the first column and subtract the second column, and we see that we have a negative 220 milliseconds as the difference. And then we repeat this for row number 2, row number 3 individually for each of the participants, and we continue until we have all 10 participants calculated. And take a look at participant number 10, where we see that they recorded the same reaction time under both conditions, having a difference of 0. So what we see here is that this value would actually drop out of the determination of our critical value, and we now have a new sample size of 9 with data as we move forward. And so note that we only have two positive values, indicating that the reaction time was faster for participants 8 and 9 when they viewed the black symbol. The longer or the larger number indicated a slower reaction time, whereas the vast majority of participants have negative values, indicating that it took them longer to pick up on a black symbol on a computer screen than a red symbol. And so what we see here is a rank ordering of the 9 scores here, so we ignore the 0 here, but we also ignore the positive and negative sign for now. So we see that the smallest difference was a 10. So remember, ignore the positive. So being the smallest, that has a rank of number 1. The largest difference as we go through we see is 505. Once again, ignore the negative, and so that's going to have the ranking of number 9. And so you have to sort of sift through and rank order based on the magnitude only. Now at this point, you see the last two columns here, ranking negative, ranking positive. So we just transfer the numbers in the ranked scores over to the appropriate column based upon whether it was negative or positive. So in calculating the ranked scores, we ignore the positive and negative, and then we go back to whether it's positive or negative in terms of moving those scores over to these two columns. So we saw two positive scores, two positive difference scores, and these two scores happen to rank number 1 and 2, and we move those over into the positive column, and the rest were negative, and we just transfer those numbers over to the negative column. So as one last reminder here, we have our new sample size of 9, and we add up vertically in the last two columns. So we add up all the negative ranks. Again, we don't have any negative symbols here, but these ones correspond to the fact that the difference was negative. So we just add up vertically, and we have a ranking, a sum of the negative ranks of 42. We only have 2 here, and that's summed to 3. So this will end this video, and we'll pick up in the next video where we'll finish off the application of the Wilcoxon t-test.